Hey, it's Jim, and this is level 1 of the CFA program, the topic on fixed income and the learning module on yield and yield spread measures for fixed rate bonds. We've had some really good conversations recently on bond pricing and the yield to maturity on bonds. What we're going to do in this learning module is just really extend that conversation, and we're going to consider 3 extra variables. We're going to consider number of compounding periods. We're going to consider the concept that some bonds have embedded options in them. And then we're going to go ahead and look at this notion of yield spread. So there's, potentially 3 really good exam questions, which is interesting and ironic that there are only 2 learning outcome statements here. Notice that we're going to have to calculate. There's that annual yield over varying compounding periods, but we're also going to have to compute the annual yield for bonds that have embedded options, and then we'll have to worry about yield spreads at the end of this slide deck. So let's go ahead and start with this concept of varying compounding periods, and we'll call this periodicity and annual yields. All right, so what do we know about yield to maturity? The yield to maturity on a bond is the required return on the bond, and it measures the return on investment, and it's going to depend on the frequency of compounding. Look down at the bottom. Issuers can pay coupons to their bondholders once a year, twice a year, 4 times a year, 12 times a year, 50 times a year, 100 times a year. I mean, issuers could do almost anything they want. Most bonds pay interest twice a year. Now, what we need to worry about is comparing a bond that's under our investigation with some other bond. Suppose that we are interested in purchasing a Milton Hershey bond that pays semi-annual coupons, and we're comparing that to a Sam Walton Walmart bond that is very similar in many different ways, but it pays coupons monthly. Wow, so how do you compare those 2 things? Of course, we need to go back to our time value of money discussion. We'll call this the annual percentage rate. And we're going to have to go from 1. So we have this original periodicity, and that's the M on the left-hand side of the equal sign, to the converted periodicity, that's the N on the right-hand side. And I'm guessing that you're thinking to yourself, you know what, I bet Jim has a really cool way of doing this on the financial calculator. And of course I do. So let's take a look at an example here. Consider a bond, face value of $1,000. Remember, the Institute doesn't have to give you that face value because all bonds mature for $1,000. Now, be aware that sometimes the Institute gives you this in terms of $100 of face value. That's just to save space in the pages of the Wall Street Journal back in the way old days. Current price of $9.50, time to maturity of 3 years. Annual coupon rate of 6%. So we take 6% times that par value or face value of the bond, and we get $60 of coupon payments. So the question then becomes, let's go ahead and calculate the yield to maturity on this particular bond. All right, so notice there's that formula in the gray box. We put $9.50, the price on the left-hand side of the equal sign. And then we put the $60 in coupon payments, right? It's a 3-year bond, so we're getting $60 in year 1, in year 2, and year 3. But then at the end of year 3, we're getting that $1,000 return of par value as well. And we're going to divide those by 1 plus the yield to maturity on the bond raised to the 1, 2, and 3 power. And so we can do this just by using our financial calculator. There are the inputs there. Why don't I show you this using our online calculator? Let me just remind you that there's really no order for you to enter those 4 input variables. Let's go ahead and start with 3 as N. We'll do 60 as payment. We'll do 1,000 as future value. 950, make it negative down here with the plus minus. That's present value, and then we have to compute I, and there you go, 7.938%. Well, let's suppose that that previous bond, which paid interest, here let me go back quickly, paid interest annually. Let's suppose that in the red box we say that the interest is compounded semi-annually. let's say in the green box that the interest is compounded quarterly. So we're just going to go back and use that equation that I showed you just a moment ago with the m's and the n's. And I will go ahead and say that the reading gives you absolutely no advice on how to solve this other than providing you with a solution using Excel. In fact, later on in this slide deck, we're going to solve for a z-spread, and the reading says, hey, just use solver in Excel. So I'll go ahead and show you how easy this is. But before I refer to the calculator, look, what we're going to do on the left-hand side of the equal sign, we have that quantity raised to the first power. And on the right-hand side of the equal sign, we have that quantity raised to the second power. And we're trying to solve for that APR2. The 2 means semi-annual compounding. So you got to go back to 9th grade algebra. Wouldn't it have been great if you paid more attention back in the 9th grade? So what we're going to do is we're going to take the square root of both sides, and then that makes life really, really easy for us. All right, so let's go ahead and look at our financial calculator here. On the left-hand side of the equal sign, we have 1.07938. So let's go ahead and take the square root of that sign. Here's just the square root right there. So we have 1038 something on the left-hand side. And then we have the 1 plus, and we're solving for that variable in the numerator. And so all we need to do is subtract 1 minus 1 equals, and then multiply both sides by 2 times 2 equals, and there we get our 7786. So this is the yield assuming semi-annual compounding. Let's go ahead and do it for quarterly compounding. Let's start with our 1.07938. And since we're compounding this 4 times, we're going to have to raise this to the 1/4. So we'll need our y to the x button. So hit y to the x and then 0.25 equals. And then we'll just do the same thing, right? We're going to subtract 1 from both sides and then multiply by 4 and hit the equal sign, and there you get the 7712. So if you go back and look at the reading just leaves you kind of dumbfounded unless you have great memory of 9th grade algebra. So that's a really super quick way to do it. All right, let's go ahead and kind of summarize what we did in those previous calculations. What did we find? We found that when we did annual compounding, we had the highest bond yield. Let's just go back there. What was that? 793, and then 778, 771. All right, so that makes sense because less frequently reinvested coupon payments, which means there's lower accumulation of interest. For semi-annual and quarterly compounded, we just kind of flip it over. We're going to have a slightly lower yield to maturity because there's more frequent reinvestments. Now we need to ask ourselves the question, here we are in the 2020s. What did bondholders do back in the 1920s or the 1820s? So we have calculators, we have phones, and we have this access right at our fingertips. So we know that there are 365 days in a year. Some years have 366 days. We could go ahead and memorize. January has 31 days, February 28, sometimes 29. We could do all that kind of stuff. But look over on the far right there. There is a convention to just say, you know what, we're not very smart. Let's just assume that every month has 30 days and that the year has 360 days. So we use that convention mostly for corporate bonds, but then we use the actual days from coupon to coupon and coupon to maturity date. This is used for government bonds. So look at the green box at the bottom and the blue box at the bottom. That's probably the good exam question. What's the difference in terms of yield conventions? Corporate bonds, the old time stuff, we're not very smart. Government bonds, we're super smart, and we have computers at our fingertips. Now, what this does is this has great implications for what we're going to talk about later on in this slide deck. We're going to call this the spread. And we're interested in determining the difference between the yield to maturity on the bond that we're investigating and the yield to maturity on a benchmark government bond. Let me go ahead and just pick an example. Suppose our yield to maturity is 10% and the yield on a government bond is 6%. So if we're comparing those two, we need to make certain that we are, here, let me go back here real quickly. We are comparing our corporate bond with our government bond with one convention and another convention. So we're probably going to have to convert that yield to maturity. This is called the government equivalent yield. The true yield on a bond, this counts the weekends, it counts the leap years, it counts all of the holidays. Street convention ignores all of that stuff. So look at the bottom there. The aim is to get to the spread over that government yield to maturity, but you need to be aware of these subtle differences on this slide and on this slide. So let's go ahead and look at some equations for calculating yields. Simple yield, this is used for specific countries, government bonds, Japanese government bonds in particular. This is relatively straightforward. Coupon payments plus some kind of expected gain or loss from the straight line amortization schedule divided by the flat price of the bond. Recall we had a good conversation on the difference between the flat price and the full price. We talked about accrued interest and all that. The reading doesn't really tell you much about the simple yield. In fact, there are no problems in there, so I'm guessing you probably won't have to do that. Current yield, this is super common. You might have to do this. This is just annual income. Remember, annual in the numerator divided by the current market price. So that gives you the current yield. Yield to maturity, this is what we computed just a few moments ago with that annual pay corporate bond. What was that number that we had back here? 7.938%. So there's a repeat of the equation down at the bottom. We'll do this another time or two before this slide deck is over. But let's go ahead to get to what's arguably the most interesting part of this learning module. What did I say in the introduction? That some bonds have what are known as embedded options. They can have a call feature, they can have a put feature, they can have a convertibility feature, they can have all different sorts of features. We'll talk at length in level 2 about those embedded options. The focus here in level 1 and in this particular reading is on a callable bond. So before we get into the mathematics of this, let me go ahead and just give you a story. I say this to my students every semester. I look at them and I say, hey, next time you see your grandparents, ask them, when they bought a house in 1980, what was the mortgage interest rate on their loan? And my students look at me like I'm Indiana Jones or somebody, and they say, Jim, how are we supposed to know that kind of stuff? And I always respond by saying, all good finance students should have an historical perspective on interest rates. But then I tell them, I say, look, mortgage rates back in the early 80s was 15%, 17%. I said, after Ronald Reagan became president and then appointed Paul Volcker as the chairman, interest rates substantially dropped. And then my students say, oh, I know where you're going, Jim. Our grandparents, they refinanced their mortgage at the lower interest rate. And I say, of course. So a callable bond is exactly that same thing. But while grandparents only had to call one financial institution to refinance their mortgage, think about what these issuers have to do. They would have to call thousands of bondholders, maybe hundreds of thousands, maybe millions of bondholders out there. So in order to avoid all of that extra work, they just attach a call provision to the bond that says, look, whenever we want to, and of course they're only going to do this when interest rates fall. When interest rates fall, we're going to force you to sell the bonds back to us. So we need a measure that explicitly tells us what the yield is on a callable bond. We call that a yield to call. I'll show you how to compute this here in just a few minutes, but it's exactly the same as it was in our previous calculation with two exceptions. First of all, we're going to have to worry about the N. Now, in yield to maturity, the N is always the maturity date on the bond. But in a yield to call, most bonds have deferred call features. So if a corporation issues a 20-year bond, it might say, we can't call the bond for 7 years. Well, if we're computing yield to maturity, we would put an N of 20 in there. If we're computing yield to call, we would put a 7 in for N. So that's the first adjustment. The second adjustment is, look in the numerator there over on the far right. That's known as the call price. What the issuer will do is they will return that $1,000 in par value, but then they'll give you something extra as a bondholder. Maybe it's 6 months worth of interest, maybe it's a year's worth of interest, maybe it's some other number, but that call price is something more than $1,000. I'll show you that here in just a second. And then the yield to worst is the idea that, you know what, what's the worst thing that could happen? Is the bond called? Is it not called? So look down at that bottom block point. This is a super easy calculation. Just take the minimum of the yield to maturity and the yield to call. If the institute asked you for the yield to worst and gives you those first two numbers, oh my gosh, that's the easiest question that they could possibly ask you. Now, another consideration that we need to make, we talked about in a previous learning module, the difference between an on-the-run government bond, which is a bond that was just recently issued, which means that its coupon rate is probably pretty close to the yield to maturity, which means that its price is pretty close to its par value. On the other hand, off-the-run government bonds, these are known as seasoned government bonds. These are less actively trading. They might sell for big discounts. They might sell for big premiums. But the interesting thing here is that, remember, we're trying to figure out the performance of our bond versus the performance of a government bond. So if our yield to maturity is 10%, and the yield to maturity on an on-the-run government bond is 6%, well, we can be pretty confident saying that that spread, 10 minus 6, is going to be equal to 4. But suppose there is no such thing as an on-the-run government bond. Suppose our bond was 20 years and there are no 20-year government bonds out there. So what we're going to have to do is we're going to have to find the nearest seasoned government bond to use as the benchmark. And then we need to worry about these other things. Let's work through an example here. We have a bond, face value of $1,000, coupon rate 6%, paid semi-annually. So 6% would be $60 every year. Chop that in half. That'll mean $30 every 6 months. Market price $980, maturity in 5 years. But look at the next one there. It's callable every year after 3 years. 5-year bond can't be called for 3 years, so there's that deferred period. So if you're the bondholder, your bond can't be called in year 1 or 2 or year 3, not until the end of year 3. And then there's the call price. So what is this issuer doing? The issuer is paying the $1,000 plus an extra $50. We can do that current yield without my help, without a calculator. Just take that $60. Remember, annual coupon rate for current yield divided by the 980 gets you 612. Yield to maturity, we've already done that. I'll show you the calculator here in just a second. Yield to call, which we haven't done yet, so we're going to have to make some adjustments on there. Look at the call price over there on the far right. So that's $1,050. Look up under the green, yield to maturity, face value. That's going to be just $1,000. So let's go ahead and get our calculators out. I'll show you on our online calculator. Let's do YTM and YTC. Remember, there's really no particular order that we need to worry about. So let's do 980, make that negative. That's present value. Let's do 30 is payment. 1,000 is future value. It's a 5-year bond, so we'll make N of 10. So let's hit compute I, and there you get the 329, but that's semi-annual. So we got to multiply that by 2, and there we get 6.475%. That's the yield to maturity on the bond. That will be the yield on the bond if the bondholder holds the bond to maturity, receives all the coupon payments, and then reinvests them at the yield to maturity. All right, let me clear that out. Let's go ahead and do yield to call. So what did I say? We need to make a couple of adjustments. Well, one of the adjustments is not the payment, right? That's still 30. One of the adjustments is not the price. That's still 980. Make that negative. So that's present value. But now we're going to make the call price not 1,000, but $1,050. And N is going to be 3 years from now when that bond can first be called. So we'll make 6N, and then we'll do compute I. That gives me that semi-annual number, multiply that by 2, and you get 826, and there it is. So I'll let you guys pause the video and confirm the 7682 and the 7331. Just make N 8 for the second one and 10 for the third one. And then the yield to worst, what was I saying just a few minutes ago? This is the easiest question. So what are we doing? We're comparing the 6475 with the 82, the 76, and the 73. So the yield to the worst is the yield to maturity on the bond, 6.475. Now, I've been dancing around this idea of spreads. What did I say a little bit ago? 10% minus 6% equals 4%. That's the G spread. That's called the government spread. So all we need to do is take the yield on our bond, subtract the yield to maturity on the benchmark bond. And by the way, they have the same maturity date, or nearly the same maturity date. The Z spread, this gives us a much better picture of what's going on over the entire spectrum. What did I say earlier? If that was a 20-year bond, that G spread on a 20-year bond, that's going to be a fixed spread. And you're asking yourself the question, okay, in our example, that was 4%. Does that really reflect the entire yield curve? And the answer is, of course not, but it's a good place to start. So what we do is we add some extra stuff to it and call it the Z spread, the zero volatility spread. And so the mathematics of this are exactly like we just did back here. And let me go back here. Exactly like we did with yield to maturity, exactly like we did with yield to call. However, the slight adjustment that we have to make is so massive that we probably can't do it with our computer. So I want you to think about this. Look at that equation in the green. So we have present value on the left-hand side. So there's the 980. We have the payments on the right-hand side in the numerator, so there's the 30, right? And then at the end, you have the $1,000. But now what we're going to do is we're going to divide by 1 plus, of course, we're compounding, right? 1 plus the interest rate, and then we're dividing, so that's discounting. What we're going to do is we're going to go ahead and look at not just the 20-year government bond, but we're going to look at the 1-year government bond, the 2, the 3, the 4, the 5, all the way out to 20, and we're going to look and find what are those spot rates of interest. Sometimes we call those zero rates. So the 1-year rate on a 1-year bond, the rate on a 2-year bond, and 3 and 4 and 5. So notice in the denominator, we say 1 plus lowercase Z1 and Z2 and Z3 and Z4 and Z5. All right, so what we're doing is we're taking a look at the yield curve. What yield curve we know can be upward sloping, yield curve can be downward sloping, yield curve would be flat. If it were a flat yield curve, then each of those Z1 and Z2 and Z3, they would be the same number. But then what are we doing? We're adding Z. We're adding a spread. This is a Z spread. We're adding a constant Z spread. So look in the denominator every time. That's the same uppercase Z. We're adding a Z spread, which will equate the present value of those cash flows to the market price of the bond. And that Z spread is going to give us a great indication of what kind of risk is associated with investing in our particular bond over the entire yield curve. The Z spread, as you can imagine, is way more informative than the G spread. Now, what the reading does for you is say something like, oh, by the way, you can use Excel to compute the Z spread. And so during the course of the exam, you can say, hey, does anybody have Excel around so I can do this? So clearly the Institute is going to have to give you a bunch of information, but I think it's more likely that they'll hit that third word in there. Okay, compare, calculate, interpret. Yeah, we're going to have to interpret that Z spread. So I've just given you that interpretation. Now, what happens if we're considering a bond that has an embedded option in it? Well, if you go up to the Z spread, notice there's a 1 and a 2 and a 3 all the way out to 20 in the denominator in my example of a 20-year bond. But what if this bond can be called in 7 years? Oh my gosh. So we need a new measure of a spread that considers the value of that embedded option. And that's called, as the name suggests, an option adjusted spread. Now we get into tremendous detail in level 2 on computing this option adjusted spread. I'm guessing since the Institute doesn't spend more than a paragraph or so on this AOS, all you need to know to meet this particular LOS here is to know, look at that equation down there at the bottom, the Z spread minus the option value. So I mean, seriously, if in the question stem, the Institute gives you the Z spread and they give you the option value, then you'll be able to compute the option adjusted spread. So it should be pretty straightforward on the exam. And then the final spread is an I spread. Man, when we do derivative securities, in particular swap contracts, we're going to really focus on the I spread. All we're doing is taking a look at the difference between our yield to maturity and some kind of a yield that is present in the swap market. Now, we'll talk at length about fixed for floating rate swaps, currency swaps, all sorts of crazy swaps that are out there. But we can use this spread as a measure of what's going on in the highly liquid swap market. And so that's the advantage of using the spread over these other types. So let's go ahead and finish with an example. So we've got a bond here, 4 years, 3% coupon, yield to maturity 3.5, swap rate 2.2. So here, let me go back here. There's the I spread. You already know what that I spread is. Whoops, I went in the wrong direction there. Government rates 1, 1, 2, 2. Yeah, there you go. So maturities are 1, 2, 3, 4. Current bond price 97, 50%. So they're 97.50. Notice there's a percent sign there. So this is based on 100% of par value. So you don't need me. You don't need your calculator to compute the G spread, 3.5 over 2.5. But let's make sure you get this right. So this is we have a 4-year bond. So we need to go to that government 4-year yield to maturity. That's the 2.5%. So 3.5 minus 2.5, that gets us 1. The I spread, 3.5. There's the 2.2% swap spread. So that's an easy 1.3%. There we go. Look down at the Z spread. Solver finds Z by setting the bond price. All right, so there's the Z spread of 1.22. And that takes us through these two learning outcome statements. I want you to go to the learning module questions at the end. There's a handful of them. You'll need your financial calculator. Recall in recent recordings, I said you could probably do those 5 or 7 questions in 5 or 7 minutes. Give yourself 15 minutes to do these. But what those problems will do, since this stuff is in your brains, it will cement it. So work through some of these problems and you should be able to do well on these questions on the exam. So, hey, thanks for watching. Have a great day and good luck studying.